This is going to be a little bit of a surprise. First of all, I love that I'm going to have to look at those glass walls to see the monitor. That's pretty cool. But I got it. I got a line of sight. It's my favorite trick when reading people's poker hands too, is to look off their glasses or something. So I love trivia. My former coworker Mitchell is here. He's a big trivia fan. Does anybody know what the acronym, other than Mitchell, TCONA, T-C-O-N-A, stands for? Trivia Championship of North America. And we have, I don't want to embarrass him. Yeah, I do want to embarrass him a little bit. But we have a TCONA competitor and champion? Team? Not yet. Yeah, he took home dough from trivia. So I really don't want to disappoint him. And I really don't want to disappoint any of y'all. But the truth is, surprises happen. And I really had this idea of a real-time trivia game, and I would like real-time poll you guys, real-time troll you guys, with trivia questions saying, hey, just go to this URL. I think the URL's on the bottom of every slide, but there's just not a whole lot there. It's react-trivia.herokuapp.com. But if you can't see it, it's because it's not fully done. It's not done enough. There is some real-time communication happening, and that was kind of like the crux of what I wanted to get to. I also assumed that I would have crushed all that real-time communication and Redux stuff and moved on to fancy styling and lots of trivia questions and animation, right? So first of all, this is not the talk you were looking for. React, Redux, and trivia. It should actually be called like Redux, ES6, and almost a trivia app. You guys can download the source code for this. It's not that bad. I don't mean to crush it. It just doesn't look like much. It's like, so if you guys were a house of project managers, I'd be a lot more nervous. Because it's like, I know you don't see anything when you go to the homepage, but it does all this stuff under the covers. So you're all developers. So if you clone the repository, you'll see that I definitely put a lot of work into this. And yeah, I was not trying to pull this off. Where did I get stuck? Well, I figured since I'm, telling you I didn't get where I wanted to get, I think it could be a valuable thing to share. Where did I get stuck? So, who's worked with Redux here? Can I see a show of hands, just so I know like people's familiarity with Redux? Okay, great. So that was me at the beginning of this. I started this, my first commits on this were over a month ago. I'm not saying that it's that hard, but I come from a different background. I've done, Meteor is like my JavaScript platform of choice, and I've organized that meetup. Some of y'all have been there. That has a particular state management model, and Redux has a particular state management model. In particular, you don't want to have everything all in one. So there's a function in Redux called combineReducers. And it's basically like, how do you set up the overall structure of a Redux app? So it took me quite a bit of time to get my head around that. The good news, and I've seen this proven out on production projects, is that once you get the structure set up, adding new functionality is literally so simple. And I'll explain why. Well, basically, you just add new actions, add new reducers. I worked at a client that had a really sophisticated project, and it was to manage, it's a stock photography company, and it was for users to manage their stock photos, and it was a really sophisticated Redux app, and people, including myself, would just jump on there, add new functionality by just adding new exports to a file. But getting your head around the initial structure, I'll tell you, it's not easy. But that's the least of it. It's really, React is JSX, And JSX gives you all these ES6 things. And that's really great. It's really expressive to use ES6. Unfortunately, I ran into some interesting tricks with ES6. So export default, all right? So like, whereas in Node.js, you have module.exports equals some object, ES6 has export default, which is supposed to be about the same, but it's tricky. Sometimes you export, and there's different ways of doing exports and imports, and sometimes they don't match up, and your eyes just don't see it because it looks like it should do what it does, and it doesn't. Also, running ES6 code. So if you've seen import statements, has anyone seen like import blah 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 from blah 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 in ES6? Well, try pasting a file like that into the browser, and it won't work, right? So my point is, there are different execution environments. There's Node 5.5, Node 6, this browser, that browser, and their support is widely varied. So on the server, you might actually use an executable called babel-node to execute your code because it understands import statements. You'll add a bunch of things to package JSON, Babel presets, and all this stuff. And like, frankly, this is like a pretty schizophrenic time for JavaScript. ES6 is not quite there, so the tooling can be a real pain in the butt. And module load order, that matters. I can't even represent. Obviously, when you say you import a module, that's one thing, but I don't know, I'll just say that I got stuck on that, and I'll move on ahead to some things I can explain better. And Redux dev tools. Okay, so this one really, really pissed me off. So Dan Abramov, awesome Redux author, has written these Redux dev tools, right, that plug into your browser and show you all the actions. This won't make sense to you if it's your first time with Redux, but I'll get into that later. When the dev tools are loaded, it sometimes breaks your code. And yes, I have issue numbers with giving up URLs to these issues, like documenting this fact, like I'm not making this up. I don't know how he developed things to the extent that he did with some of these breakages, but anyway, Redux DevTools is currently off in this project, and that's why. Because of course, it's a rainy day and you're trying to get this thing ready, and Redux DevTools have been eating your time for half a day before you know it. And then you don't have as many trivia questions. Wah, wah. So no time for animation. Sorry. Wow. Anyway, having laid that all on the line, a lot of things were easy. There's a wrapper called Redux Act, and it makes structuring your Redux actions much simpler. This is nothing like sagas or any of some of the other more far out things you might have heard of. There's also a thing called Flux Standard Actions. This reduces boilerplate, and I'll show you examples of it. It was really, really easy compared to figuring things out from scratch. WebSockets, actions that are taken at the client being sent to the server. The server updates. It sends updates out to all the client. That whole real-time thing I promised to talk to you about, it actually is pretty darn easy, and I can definitely show you how that works. With raw WebSockets. And like I said, extending the app. So in other words, adding new actions to the app, adding new views, adding new reducers is all totally easy. And although I probably won't do it live, so I'm nervous enough about just presenting this stuff with what I have. Certainly afterwards, I can show you with the app code. If you pull it down on your machine, any of the things that are broken with this app, literally there's a series of like a handful of 10 to 20 minute changes at most, right? So if you want to pair up one of these, I'll show you. It is pretty easy to extend it. So really, I think the real title of this presentation is Building Up to Redux, right? Learning the fundamental concepts that apply to Redux, and there's a pseudonym because, I'm not Dean Radcliffe, I'm somebody else. So anyway, I did promise you some trivia. Let's get to a fun trivia question, all right? JavaScript took a different amount of time to develop compared to most languages. Did it take 10 hours, 10 days, 10 weeks, or 10 months? First answer?
10 days.
10 days. 10 stinking days. Does anyone know the author of this? I don't have a slide for that. The author of JavaScript? Brendan Ike. Yay! Brendan Ike. So yeah, there's technology trivia. A few of these mattered in here, but I like this one too. So you see, I'm all glowing green, right? Because I like Mountain Dew, and Mountain Dew was originally slang for coffee, Red Bull, whiskey, or moonshine. Moonshine. All right, that kind of guy. Moonshine. Yeah, and there's an interesting and relevant story about this. So yeah, Mountain Dew comes in a jug, and the Mountain Dew company is aware of this, in case you weren't sure. Just like Coca-Cola is acutely aware of its origins as well. Okay, so the story about this is when you wanted to get Mountain Dew, all right? So moonshine was, prohibited the sale of, homegrown liquors and stuff. So there'd be a stump in the woods, in the mountains, and you go up to the stump, and you'd have your money, and you put your money down on the stump. Here's the money. Here's the stump. Put your money down on the stump, fire a rifle into the air, and you wait back. Then you wait, and then you hear another rifle shot. And then that means that it's good to go back to the stump where your money has been replaced with a jug of Mountain Dew, and you can take it on your merry way.
It's also a vote for Trump.
What's that?
It's also how you vote for Trump.
It's also how you what?
Vote for Trump.
Vote for Trump. Also how you vote for Trump. Yes. It requires, well, I'm not going to go there. So I'll get back to why this is relevant, but you can see that in that transaction, both sides need to know about the stump, but they don't need to know about what? Each other, right? So that's going to come into play in Redux. So, reduction, reducers. Like, how many times have you been walking down the street and seen a reducer? So, first thing in building up to Redux, you got to know is what reducers mean and what it means to do reduction. And so here are a few things that might help you with the thought of reduction, since I noticed that less than 10% of y'all work with Redux. So reducers and reduction. Take many into one. All right? E pluribus unum, which means literally something like out of many, one. But anyway, many, one. And so one thing that takes many into one is an aggregation operator in SQL. Like the sum operator takes many records, produces one sum. So if you imagine this sum operator working as you go, it takes a couple of records, it sums them, a new record, sums them, new record, sums them. So it's incremental. I don't mean to imply that it's all at once. It's one step at a time. And it adds a piece to the whole each step that it goes. But that is the essence of reduction. Now, if you're learning ES6, or if you've been a user of the underscore library, or if you know reduce by a name that it goes by in Ruby, anybody know the name of reduce in Ruby? It goes by inject. You might have seen inject. So I talk about OG reducers. Original generation, OGen for Mitchell over there. Original reducer. So basically a reducer function. So before Redux came along, there were reducers, man. They were everywhere. And ES6 has a function on arrays called array.reduce. That's this 124.reduce. So a reducer function takes piece 1 and piece 2, and it returns an aggregate of just those pieces. Okay, so a reducer function takes one piece and another and returns the combination of them in whatever way it defines. This is a sum reducer, and that's why it's named that. So in the example of 124.reduce sum reducer, 2 calculations were computed, they're in comments. 1 and 2 were added together 3 and 4 were added together, 3 being the previous reduction, and the result 7 was printed. You can go to your JavaScript console and type this. This is like reduce in the vanilla sense. What's important is that though you have 3 items in the set, your reducer function is called how many times? Just twice, because the first piece is pre-filled. It'd be nice if Redux chose to inherit this idea of reducers, but guess what? They have their own special semantics for reducers, which is really unfortunate because your array.reduce, your JavaScript native reduce, works a little bit differently, but it's not too hard to understand. So here are some things you can do with reducers. Oh, in the second example, sorry, we're providing an initial value as the second argument to the reduce function. Okay, so it's doing the same sum, adding it on top of 35. And in this case, which is more similar to the Redux case, and that's why I put it on the slide, you do have 3 calls to the reducer function with the initial sum, initial value plus each term. So this second one is more similar to how Redux reducers work. The issue that I think, to give them credit, just imagine the rationale, is that the problem with this is that this 35 initial value is living outside of the reducer. And so I think what they were thinking with Redux reducers is, what if the reducer, when called the first time, produces its initial value? So that's pretty much the way that reducers in React and Clojure, by the way, are expected to work. Is if they're called with no arguments, they return the initial value. What's up, Brian? So what can you do with reducers? Well, anything that produces a new state, given an existing state, and a new data item. So you can build up an array of all the items. That's like aggregating. You can build up a total, like the sum example we saw, or you can only keep the most recent item, right? So you don't need to keep a memory of everything. A reducer is only required to return a new state given an existing state and a new item. So here's what Redux reducers do, is they provide the initial piece if they weren't given. So in this example, it's very much like the sum reducer that we saw before, except if piece 1 was not given, instead of doing a sum, it returns 0. It returns an initial value. So in Redux, you have a large state tree, a single global state object, and you can put reducers in charge of each state. So I'll show you the trivia game object model in a little bit. And so if, for example, if this were a trivia game, there would be a question and there'd be responses for each question, right? Each one of you who's on your mobile phone would give a response. So there'd be a reducer that aggregates the responses that are given for a person, right? So that's how to think about reducers' role in Redux. You put them in charge of each domain. There'd be another reducer for the game, because as an administrator, I want to be able to end the game. And when the game ends, a game reducer will change the state of the game, and so forth, for each part of the tree. That's how to think about your decomposition. Any questions so far on reducers and Redux? Okay, cool. If people labored their points enough, is what I can tell. So let's move to a trivia question, because those are awesome. Trivia. The dependency inversion principle applies to Redux because Redux depends on React, historic reducers know about actions, React depends on Redux, or what the? Dependency inversion principle? First answer.
Second.
The second one. Yes, correct, sir. The store and reducers know about actions. So remember that Mountain Dew and the stump example? It was really nice. I didn't have to know who was delivering the moonshine. I just knew about the stump, and he knew about the stump, or she. And because we had an intermediary, we did not depend on each other directly. We depended on a third party. And that is the dependency inversion principle. I'm going to take this to a little segue to a job interview question that I knew I would bring at one time. So I was interviewing for a job, and I had gone through about 10, basic questions, object-oriented, what is polymorphism, what is this, and I'm like, boom, boom, boom. And then I got to, what is the dependency inversion principle? I drew a complete blank. I got the job, but it was one of those things that was burned into my head. It's like, I want to know the dependency inversion principle, and I want you guys to know the dependency inversion principle. And the thing is, it's not as complex as it sounds. And so the answer is number 2. And here's an example of the dependency inversion principle in action. This is somebody soldering a lamp directly to the wires in the wall. Yeah. We don't do that. We have a plug. And lamp makers know the shape of the plug, so they know what shape to make the plug in. House wirers know the shape of the plug. We agree upon the shape of the plug. And I, as a house wirer, don't need to ask your requirements. What kinds of things are you going to plug into this? That whole requirements gathering stage. Doesn't matter. We've decided on an interface. So anyway, you guys will now be able to at least somewhat answer the dependency inversion principle question if you get it. So here is how that kind of works with Redux. You have state. That is your global object tree. It says that my answer is currently the correct answer for this trivia question. It says this current trivia question is this, and I'll take actions. And so in this case, it's kind of a weird diagram. It is true. Reducers know about actions. They know which actions to change the state. So they also know about state. But in this case, it's kind of a weird diagram because actions are the stump, right? Anywhere in the app, I can generate an action. I don't need to know who's looking at it. I can generate an action, send it on its merry way. And reducers know about actions, so when they get actions, they can change the state based on those actions. And so it looks like this over time. There's an initial state, and then action 1, action 2 are serving to apply that reducer function to modify that initial state into additional states. You see, I really did want to have a working Redux app. That's why I didn't spend much time on the diagrams. I just drew them, and I didn't do SVGs or fancy stuff. I'm just get this done. So anyway, that is what's happening over time, is that actions are changing the state. So if you look at the Redux documentation, and this is the official way, and you actually undergo this kind of Stockholm syndrome, where you know that this is evil and it's your captor, but you start to think, oh, this is normal code. Sure, this is normal. I have a switch action.type. Yeah, sure. And then actions. I should have had a slide that showed the 2 important pieces of an action. There's a type field, just by agreement in the Redux community. An action has a type. So you'll just write this gigantic switch case statement, and you'll just switch on the type, and then in this case you see returning object.assign, and it's taking an empty array, it's adding the state to the empty array. This is like _.merge, where it's a cumulative add of this. And then we just know that on the action object is a field called filter. And so then we'll just merge this object after state, visibility filter, action filter. And then default returns state, and then state equals initial state. And you start to think like, oh yeah, I'll write my apps this way. This is like the Redux way. Well, it doesn't have to be. And because I know, and you all should know, like the original generation reducer functionality, original generation reducers don't look anything like this. And I always think as a principal, in application code. Well, you know, React is hot this year. It was hot last year. It ain't going to be hot 5 years from now. The more code you write, or maybe it is, but I mean, do you want to bet on that? The more code you write, where each function of yours is Reacty or Reduxy, that's stuff you have to port. One of the beautiful things about Redux is that you can write pure functions. But if your pure functions look like this, the official way, you're not going to want to use them any other way. They're going to be pretty hard coded. So I think that a great option is Redux Act. And a library that I'll show you what it is. So here is an action. So never mind this join player-player preamble, right? So a generic Redux action is a plain old JavaScript object with a type that's a string. Oh yeah, you also want to get your string constants all in one place. And Redux Act helps you with that. And then some set of fields in addition to type. So Redux Act uses a library, uses a convention called a flux standard action, where there's always a field called payload. And you can put whatever you want in there, but it's going to be in a field called payload. So it just takes that Redux convention one step further. The other thing Redux Act does is, and Redux in general, prefers that you have action creator functions. Action creator functions take an object and return an action. So join player is what happens when I open up the game and you guys sign on to this game and enter your name so I know who you are, and that sends a join player action. And rather than having like several places in my code that create these action objects, you just have a function called join player, and wherever your JavaScript can see the join player function, it can call that to generate an action. So in this case, the Redux Act library uses flux standard actions. It gives you a method called createAction, and you pass a string, and then that join player that you get by calling createAction with the string, that join player object is something that you can pass around your code and call anywhere in your code. So whether you're using Redux Act or not, you can look into this flux standard action pattern. It really makes things easier. So as I went through this, I realized that there are a couple of things that are actually interrelated. And the first two I've defined, they are actions and reducers. And in case it wasn't clear, a reducer listens for actions, like that ugly switch statement, and then it changes the state, and then it returns the state. So those are actions and reducers. The way that they're related is that reducers have that giant switch statement, and what it's like switching on is the name of the action. So whether or not you have direct JavaScript imports, your reducers know about your actions. The other thing is called selectors. So your state may be some giant object. So for example, one of the things in this trivia app is if someone answers, they want to know if they are the first answer. So the state may accumulate all the answers. And then you're going to have some complex function that says, I know my answer, I know all the answers. Am I the first answer? Am I the right answer? There's all this derived state that comes from state. So selectors are a Reduxy way to put your derived state calculations, and they're memoized, so they don't run any more than they need to. So they're optional, but you can group them together. Actions, reducers, and selectors, and these are kind of like, actions are the update statements, or like, actions are like the SQL strings themselves. Reducers are the things that apply them, and then selectors are the select statements to get them back out. So I found it useful to group them together into models. So, for example, a round, right? A trivia, each question I've called a round. One part of the round is the question that's being asked, and then another part of the round is the responses. So you want to have an initial state? Well, the initial state, until a question has been provided, is an object that's an empty question and an empty set of responses. It's kind of obligatory to provide an empty object because React expects to call your reducer once, and get something back. So if the round hasn't started, you need to provide like an empty thing. So this is a round model. And then the actions that are part of the round are answering a question, and the parameter to answering the question is the choice that you're making. I'm answering that question with a choice. And then the admin can call the advanced question, so to move on to the next question. And then some of the selectors that pertain to the state that the round manages are whether the question has been answered, because maybe we're going to lock out future answers when it's been answered. And the answer state, which can be pending, confirmed, beaten, correct, incorrect. The calculation of what that state is, which of course is going to affect how the UI looks, is some calculation based on those question and responses field. So those can be selected. So that's the idea of grouping things together in a model. And here is like the actual code of the round model partially implemented. And it's probably a little bit small to see on the slide, but you can see that this create reducer syntax, it's pretty nice because there are no switch statements. Let me break down this create reducer syntax. So reducer might reply to multiple actions, right? We said there are multiple actions that can affect the round. Advancing a question being one of them. So at the very top of this, we create an action based on the string advanced question, and we put it into a variable called advanced question. Create reducer takes a map or an object where the names of the keys are the actions you want to respond to. So you don't write a switch statement, it kind of writes a switch statement for you. So dealing with the advanced question action is done by the following reducer. You get the round, and you get whatever the payload of the advanced question action was. Now we use underscores as a convention to say, I don't really care what the payload was. Like advanced question doesn't take any arguments, so we don't care what it is, and we're going to return an object that is all the fields that were currently in round. This is using this triple dot object rest spread Babel plugin, which caused me a lot of grief, but it's very elegant and expressive. But beware moving code like this around. You need those Babel settings. So take the round's existing state, create a new object from it, and then the question field, get the next question. Whatever this question model says is the next question after this one, and just overlay that stuff. And that's how you're going to change the round. Joshua.
This is Redux app.
This is Redux app in particular. Yeah. This is what gets you away from writing the switch statements. And also it gives you, it gets you away from writing the switch statements. So this is your reducer for that. Also you see the initial round is called out. Here is your initial round. Maybe this should have been an object in an array, but there's your initial round, and then you pass that as the final argument to create reducer. So it just kind of separates things. It lets you have OG reducers, right? It lets you use those. So here's what that looks like in terms of that chain diagram. Reducer equals create reducer. So your red keys are the actions that can be taken on this state. And then you write these pure functions, these pure reducer functions, and then you pass the initial state in green. So it's just nice. It kind of sets things, it keeps things separate, right, instead of mixing them. All right, eyes are glazing over. I feel the need to change this up a bit with a trivia question. Which company first introduced XHR, the foundation of AJAX? Google, Netscape, Microsoft, or Apple? Netscape. Anyone else? Google.
Microsoft.
It is Microsoft. This is one of my famous fails that I remember. I saw XHR in IE, and I was like, who would ever use that? This was over 13 years ago, so cut me some stuff. Microsoft in some version. Okay, so that's all the building up to Redux stuff. reducers, ES6, object rest spread, all of that stuff. What did it take to make a real-time app? Well, I feel bad that I haven't showed a demo, but again, the demo, there is some real-time functionality available at reacttrivia.rogueweb.com, but it's not enough to like probably make a convincing demo. So I'll call out the most useful parts of the code here. So to make real-time work, the server in this case has a Redux store. Who wants to deal with databases when you're just trying to get a demo app up for the awesome React meetup? So you can actually use Redux on the server, right? You don't need an actual database. Sure, it's not going to survive if the server goes down, but I'm like, hey, you know, like for the sake of tonight, sure, why not? And the idea is that actions that the client does, including the administrator who's going to advance the next questions, are going to be sent to the server via WebSockets, and all the web server has to do is apply those actions to its store and then send the state back out. And not every update of state you get from the server will be because of something you did. So for example, I can answer a question until someone else answers it and the server knows about that, and then the server will push out an update to my browser that makes it so I can no longer answer the question. So what's needed to make that work is something called middleware. So in Redux, you have the store. The store, when you create the store, you can supply these middleware functions. And what middleware functions see are the actions that are coming in, and on that action that's coming in, you can write certain code to run based on that action. So in this case, this is the code from the application that any action that the client sends to its store to update its store, so like voting on a question, like choosing, answering a question, that will get sent to the server. The only action that is not sent to the server is when the server tells us, here's how you should update your state. We don't want to then send that back to the server. That'd be an infinite loop. So certain actions are marked as client-only actions, and basically there's only 2 of them in this application. So, and the main important one to be aware of is like, when the server updates your state, you don't send it back. So assuming you have an object called socket, which is a WebSocket, socket.io object, you can call it init, and then here's where you can provide the names of custom actions. And here, you're just basically sending that action down the wire, augmented with a little piece of metadata. Metadata is great for saying like, each client that connects to a trivia app is identified by a GUID, and so we're going to just augment that with the GUID as we send it down the wire. So that's the middleware that none of your actions have to be aware that socket.io stuff is happening, so that's pretty neat. On the server, you are going to be listening for events called action. And when you get one, you're going to dispatch it. That's how you update the store. That's how you update the server store. It's that simple. And then your server store has a function called subscribe, to which you can pass a subscription function. And this will be run on every change of the store's state. So basically, this is saying, this is probably what we call socket.init, because it's like the same object. Just basically send the state out. Anytime it changes, anytime the server changes the state for its own reasons or because a client modified it, just send it back out over the web. And this works really well to keep things in sync. Once the client has an action that says, on receipt of a state message from the server, update my state. And then you see by having functions, Actions.setState, by having functions that wrap your action creators, you can just say Actions.setState. That will dispatch a set state action automatically. Cool. Any questions on the real-timey stuff? I'll also plug that I've worked with the Chicago Meteor meetup for a long time, and Meteor is like a real-time framework that sends events back and forth. And like one of the main reasons I did this application was to understand real-time in a more raw sense, like just manipulating the WebSockets directly. And you can see it's really not a whole lot of code. Getting it hosted on Heroku is not that hard either. But I also have some insights, which I'll share at the next Meteor meetup that I can present on. Also, a more finished version of this app that talk about how you can use this with Meteor and some of those paradigms. But this is all just like vanilla WebSockets, vanilla React and Redux, plus that Redux act library. So I'll ask you guys. Animations? Anyone using animations? Anyone got any like tips for animating in React? I think like one of the fundamental problems there's a couple of different libraries to solve it. You can just Google them. Is that React really wants entire control over the DOM. So doing things like moving the position and even using CSS classes and CSS transitions to do transitions don't work so well. The guy who gave the last React meetup was pretty knowledgeable about that stuff. I'll refer you to Google or him for more of that information. I wanted to fit it in there, so that would be fitting for a game. And I can do a little code walkthrough. Let me see how I do that. I'll point you to the GitHub repo. Let me at least try to. Let me just try to run this a little bit. I set it up so that I could go to the browser. So let's see, what can we do here? All right, I have to show you something. I have to get connected to the Wi-Fi here, which is VSS. Okay. Let's see, now I just need to switch to that browser. Where is it? All right. Okay. So you notice when this loads, it says waiting for players and then game on. So the server actually updates itself. It's like a test script that was going on. And we have, so basically, this is responding to changes of state that the server sends out. It just isn't displaying the question or allowing you to vote on it. All of the actions are exposed in the browser on this actions object, and we can say actions.endGame. This will send an action to the server, which will cause the server to change the status field of the game, which will cause it to update, to send out a state event saying, hey, update your state, and then this will get it and re-render it. What does it say? Actions is not defined. Oh, that damn refactoring. Oh, there it did. See that game over? So actions, end game, actions, begin game. So this is like the admin would take this. So game on, game over. iterative development. That's what I got for. So if anyone wants to help me finish this, it's really closer than it looks. And I thank you guys for your time. I'm Dean Radcliffe. I work at Test Double, which is a really cool company that was encouraging me to test drive this application until I was like, oh my god, the meetup is tomorrow, and all that stuff. But anyway, Test Double is a great company. I started this out like completely test driving it until I went into like crazy refactoring mode to get it to work. And the finished version of this will be completely covered by tests. So if you're interested in working from home or wherever you like, Test Double is a great company to do that with. And I will say thank you very much for your time, guys. And I'd say let's just have some beers and come talk to me about this at your leisure. Thank you.